Hi, ever tried making your own racing game? Well, then you have probably encountered some challenges, and I have found one aspect that is especially difficult to do right for a solo developer. That is the engine sound. You just don't have a way to record all those fancy cars. Maybe you could use a recording from a dyno test. Probably not. It's too difficult to work with it. Well, I'll teach you how to get pretty good results with no cost at all. In the end, we'll have something like this. So, we will be using the Engine Simulator by Ange the Great. Thanks to this individual, the process of adding a high-quality engine sound to your game is easier than ever. Moreover, according to the MIT license, you can use this app in any way you want without contribution. Go to the official GitHub page, click on Releases, and download the latest zip archive. Next, we need an audio editing software. Personally, I will be using Audacity, but you can use whatever you want. In case of Audacity, an additional setup is required. In the audio setup, choose the recording device as the one that is receiving the sound, and choose Windows Wasapi as the host. Next, let's return to the engine simulator. For demonstration purposes, I chose another engine. To start the engine, hold the A and S keys on the keyboard. Enter the dyno mode by pressing D and press H to freeze the RPM. Return to Audacity and start the recording. Then, mute the engine simulator. Leave around 0.5 seconds of the recording. Cut half the recording from the left and paste it to the right to make the beginning and the end of the recording loop perfectly. Next, zoom in the middle. You can notice how the sound wave pattern repeats. Find the points on the left and right parts of the recording that will give you a perfect transition after deleting whatever is between them. If you wish, you can also crossfade clips. Next, test out the result in a loop. There should not be any glitches or clicks, as it will be very noticeable in a game. If you are satisfied with the result, you can export the project. Make sure to choose WAV as the audio format, because it works best for the looping audio clips. Next, unfreeze the RPM, hold R to increase it by around 500, and freeze again. While recording, hold R as it increases the throttle and influences the sound greatly. The rest is the same. Repeat the recording process, increasing the engine RPM by 500 for each clip. The last audio clip should be with the engine hitting the rev limit. Leave the dyno mode by pressing D again, and record the engine while holding the R key. Next, let's import the audio clips into the game engine. Create a new folder and drag and drop your recordings. Select every audio clip and change compression type to ADPCM and check the Load in Background and Preload Audio Data toggles. For more convenient usage of audio in the scripts, I store it in a scriptable object, so I created one and assigned the clips into the array of audio clips. In Custom Vehicle Controller, the engine is a scriptable object where an animation curve represents the torque curve of the engine. So, I create a new engine and make sure that the values of the first and last keys of the animation curve match the minimum and maximum RPM of our recordings. Now let's assign a recently created engine and engine sound scriptable objects to the Vehicle Controller and Engine Sound Manager scripts. We are ready to test out the results. The last thing to talk about is how you can implement a smooth transition between these clips in code. I create a separate audio source for every clip and hold a reference to each of them in an array. Every frame for every audio source, find the preferred RPM as the iteration count multiplied by the RPM step between the clips plus the idle RPM value. For example, for the first audio source, the iteration is 0, and if the engine has an idle RPM of 1000, then the preferred RPM would be 1000. For the second audio source, if the step between recorded engine RPMs is 500, the preferred RPM would be 1500. Next, find the difference between the current engine RPM and the preferred RPM. If the difference isn't too big, I use double the RPM step, for example. Then modify the volume and pitch. Otherwise, gradually fade out the audio source by multiplying it by a number less than 1. The volume can be calculated as the RPM step divided by the sum of the RPM difference and the RPM step. This way, with no difference, the volume would be 1. With a difference with the value of the RPM step, the volume would be 0.5, and so on. The pitch can be calculated as a ratio between the current RPM and the preferred RPM. Nothing to explain here, it's quite simple. There is some room for optimizations and improvement, but I'll leave it as an exercise for the viewer. At this point, the engine sound system implementation is complete. However, you do need a proper vehicle controller to work with it. If you are interested, check out my custom vehicle controller package on the Asset Store, link in the description. Best of luck, see ya.